The theorem of Pappus states that if R is the region in the plane with the area A, and if we rotate it about an axis that is not joining R, then the volume of the resulting solids is the product of the area times the distance that the region traveled around. That distance is going to be the circumference of the circular path that the region travel around. We will look at the special case only. Assuming that we have a region where the function f is above the function g from x equals a to x equals b. And we take this region and we rotate about the y-axis. So using the shell method, we slice it parallel to the y-axis. The volume of the slice, or a shell, is 2 pi. The radius is the distance from the y-axis to the slice, which is x. The height is the distance from the function g to the function f, and so f of x minus g of x. And the thickness of the shell is delta x. So 2 pi r, that is the circumference, times the height, times the thickness. That's the volume using shell method. And so the volume is 2 pi, the sum xi, f of xi, minus g of xi, times delta x. But we recognize that this is the Riemann sum, so it is the integral from a to b, 2 pi x, f of x, minus g of x dx. But this integral looks familiar. We've seen similar integral when we computed x bar. And so if we multiply a n divided by a, then 1 over a, the integral from a to b, x times f of x minus g of x dx. This part, 1 over a, the integral, is the definition of x bar. And so the volume is 2 pi a times x bar. If we take this slice and we rotate about the y-axis, then the distance, the path that the slide travel, is 2 pi x bar, which is the circumference. This circumference is the distance that the region travel around the y-axis. We call it d. 2 pi x bar is now d. So the volume is a times d. D is the distance traveled. A is the area of the enclosed region. For example, find the volume of a solid torus obtained by rotating a disk of radius a, center at b, 0 about the y-axis, where a is less than b. According to Pappus theorem, first, we're going to find the area of the region, which is the area of the disk of radius r, so the area is pi r squared, but r is a, in this case, pi a squared. We would also need to find the distance that the disk traveled around the y-axis. But the disk traveled in a circular motion with the radius of b, because it is rotated about the y-axis. And so the circumference is 2 pi b. So the volume is the area times the distance. The area is pi a squared. The distance is 2 pi b. So according to the theorem of Pappus, the volume is therefore 2 pi squared a squared b.